unlimited bandwidth, so I'm probably going to have to turn off my camera, but I wanted you to see my face. And I'm so grateful to have been invited. And I think that the two talks are, I love being able to follow David because he's thinking about things on a bigger, scale and a scale of care. I'm going to turn off my, there we go. Let me turn off my video. There we go. And so, and kind of those attitudes, beliefs, feelings. And so I'm going to talk about and share some frameworks to help, have helped me and hopefully help you think about cognitive things that can be assessed. And if at any time my audio starts lagging, please just jump in. I apologize. But so I'm Stephanie Gardner. I'm at Purdue University. I'm a physiologist and neuroscientist by training, but I transitioned to biology education research with basically starting teaching cures. That was my first entry point in 2009. So I have taught several cures. I've run professional development programs at Purdue and nationally to support people in their development and implementation of cures. And my biology education research, which is my area of now, mostly focuses on science practices, right? So experimentation, data analysis and visualization, creating arguments using data and evidence, reasoning about mechanisms. I've had a lot of different projects in the group. But like I said, today, what I wanted to share with you are some products that came out of a couple of NSF funded things, and then talk to you about how you could use these in terms of designing instruction and assessments related to the cognitive kind of behavioral and skills thing. And I have Paul driving my slides, so I apologize. But I figure you've done this yourself. You've had technical difficulties too. So anyway, so thank you again. So go ahead and next slide. So what I'm going to do is I'm just going to talk a little bit about biological experimentation. We'll think about it together. And then I'm going to talk about three frameworks. Two of them are ones that I helped develop, and they kind of go from the very broad down to the specific. So that's why I have that inverted triangle there. And and so then we'll have conclusions and questions. So go ahead. So what I wanted to do was create a word cloud, but since I'm not going to be able to display that, if you all could in the chat, so think a moment. You're not seeing the slides. Someone says, Sam said that. I can see them.
Yeah, I was seeing the slides. If you look at the top of your screen in Zoom, you may have to select Paul's screen. Awesome.
Good. Awesome. So then if you could think, like, what comes to mind? Just some things. When you think about designing and conducting experiments, and in biology, but if there are some chemists here, physicists, computer scientists, what does it look like for you? And just enter some words into the chat. Okay, got controls. Can I get a meaningful answer? Yeah. Replicate, start small. Yeah, the logistics of it. Yeah, literature, how much time it takes and thinking about that. Taking notes. Costs, yeah, lots of things related to cost. Giving people time to think. You have an upvote on costs. Like, what's the purpose? Yep. Okay, yeah, the ability to carry them out. The life cycle, yeah. Safety is the question. Is the question answerable? Oh yes. Cookbook versus designing their own experiment. Okay, yeah, you can keep. We have some upvotes on some of those backups. Yeah, as an instructor, thinking about that. Absolutely. Buying supplies. Yeah, budget, cost related things. Okay, so if we can go to the next slide. so this, I'm sorry, I have animation. I'm an animator. I apologize, Paul. If you just click advance. Yeah, so the first thing I'm going to talk to you about is some work that was done within a research coordination network around experimental design and assessments. And one of the activities that we did in this group, we had some biology researchers, biology educators, biology education researchers. We all came together. And this is what came out of responding to that question. It's a word cloud. So just as a reminder, right, the bigger the word, the more common it was across this group of people. And so you can see a variety of things, lots of things, the research question like people were talking about, but data, variables, analysis, hypothesis, right? So one of the things that was really salient was research question and communication, right? So not just about designing the experiments, it's like that whole experimental process from, and we had literature in the chat, but, starting from the very beginning on through to making meaning from the data and communicating those data to yourself and to others. And so what came out, sorry, go ahead, Paul. So just think a moment now, and you can put it in the chat if you want to. What are some things that your students do well, and where do they struggle when they're engaging in the process of experimentation? And it could be hypothesis-driven work, it could be hypothesis generation work, discovery. Anxiety for unexpected things. I know, related to what David was saying, being that positive, like, I don't know what's going to happen. This is great. I'm excited to find out too, that as an instructor. Yes. And the big picture. And I'm happy to talk more about that later, things I've done in my own classes. Yes. Interpreting the data and afraid to be wrong, worried about getting the right answer. Yeah, so these are, some of these kind of, these feelings and behaviors. Think too big. Yeah, all of these things. Oh my gosh, everything you're saying is what I've experienced in my own teaching cures too. Too many variables, baseline. Yeah, okay. So then if we can go on ahead then, thank you for analyzing the data. Oh yes, calculations, yes. So, so how do you know this? Right? How do you know what your students know and know how to do? So that is something that is, is a challenge, and there's ways to do that through observation, through anecdotes, and but then assessment, formal and informal. So next. So there are, and I just grabbed these. There are so many publications out there with kind of like off the shelf assessments that you could use, and thinking about not the kind of the feelings, beliefs, and attitudes. These are more about the actual conducting experiments, designing experiments. I mean, this is just a smattering of them. So there are many, but in my experience, they don't always fit my particular context and what students were doing in my class, right? So it isn't always a good fit. So that's that but there. Okay, next. So you probably have all seen this, but I want to frame out what I'm going to share with you by just going through backward design again, right? So we have identifying the desired results. You can animate in the next one. So that could be knowledge, skills, behaviors, attitudes, beliefs, right? So there's lots of things we might want to learn about what the students are getting out of our courses, and the students might want to know this too. And so then go ahead. So this really comes down to learning objectives, right, in your course, and then determining what constitutes evidence. Go ahead. And then planning the learning experience and instruction. So backward design, I'm sure you've all seen this before. Okay, then go ahead. So, sorry, there's so many animations, Paul. I apologize. Go ahead. So by doing this, right, everything is aligned, and go ahead. And the evidence is gathered to document student learning, refined instruction. The students and their learning is the focus. And then this doesn't need to be a linear process and it's iterative, and then go ahead. But everything is related, right? So having learning objectives, and I'll talk about outcomes as well, is related to assessments, is related to instructional activities. Everything is related to each other. Okay, next. So then I like this diagram, and I know different people think about learning outcomes and objectives. You can Google it, and it's frustrating because some people think about them differently. This is how I think about it. With the learning outcome being kind of very broad, and it is a statement of knowledge, skill, feelings that students could achieve, for example, at the end of a course. It could be at the end of your curriculum, wherever you're coming in here. And then the learning objectives these are both measurable. Learning outcomes, they have to be measurable, but learning objectives are more specific and in the context of a course could relate to different parts. And then you have your assessments and then how you teach. So like I said, both are measurable, observable, and they guide the assessment and instruction. Okay, next. But where do they come from? And then how general or specific could or should they be? This is something I struggle with. And so I'm going to talk about some frameworks that are very broad and then go on down to some very granular things. Go ahead. So you may have heard of this already, the BioSkills Guide. It came out of the Vision and Change. There's the concepts and the skills that came out of that. And so this was published in 2020. But related to thinking about experimentation, what they have here that I like is, there's the program level outcomes. That's that pink column under the process of science. And I kind of split both of them there if you're not familiar. And then what could be course level learning outcomes. And they created this using a variety of pieces of validity evidence. I actually maybe some of you were involved in like responding to some of these to say whether or not we felt that they were relevant and appropriate. So this, if you're thinking about like your course, so for example, study design, design controlled experiments, including plans for analyzing the data, right? So that could be something in your course. So that's pretty big picture. Next. But in this project that I showed the word cloud from, we, through a variety of means, created something a little bit more granular and something that could be a roadmap for learning objectives. And so we called these the project is ACE Bio, so assessment of competence in experimental design and biology. And so this schematic over on the left has the different areas or competency area that came out of our work. And this came out of tapping our own knowledge and expertise. We reviewed and mapped against textbooks and existing assessments out in the literature. And then we had surveys and interviews with biology faculty. And I'm going to give you at the end a link to a Google Drive folder where I put the book chapter that describes this a little bit more, and a couple of other resources too. So each of these competency areas, it has 2 to 10 concepts, each with associated skills. And I'll give you kind of an example so that when you look at this, you kind of understand it. So next. So if we look at the competency area of conclude, right? So we have a statement up at the top, and we define what that means, that competency area. So the ability to conclude about data with inferences that are limited to the scope inherent in the experimental design, which resonates with what some people put in the chat as well, kind of thinking too big, and this on the side of conclude. And so you can see in the first column what the two concepts were. So the concept of patterns and relationships, and then inferences and conclusions. And then we have a set of skills. And so to me, and I've used these in my own courses, maybe slightly adapting the language, I've used these as learning objectives for individual like days or lessons, and even outcomes in the course, right? So this has been a really useful roadmap for me in thinking about what are all the things that you need to do to make an inference and draw conclusions. And, it seems sometimes in my experience, you think it's so easy until you really unpack it and what do you need to do? And there are a lot of things that you need to do. Okay, next. But the other thing that we realized, and you know this from your own teaching, is you can't do everything, right? I mean, wouldn't it be awesome if you could take students, from identifying a gap in the literature to designing an experiment or an investigation on through to concluding the results? But yeah, that you can't do that in a whole semester, oftentimes, right? So sometimes what's on the right hand side there is like, in your particular course, in the module or whatever the size is, you may, because of the nature of the system under study or what opportunity you have, you might focus more on analyze. That's why that pedal that is bigger, or conducting or concluding. So it just, you can't always do everything. So that's what we kind of realized. You may emphasize different things. Okay, next. And there is a book. Not all of the book chapters, and they might soon be coming out. We wrote a book, and it was grounded in these competencies. So throughout the book, you can kind of see how people have used them in curricula, in courses, and so forth. So I wanted to share that with you. Okay, next. So for me, I wanted to go a little bit deeper. That's why the title of the slide is Unpacking and Unpacking. Right. So one of the longstanding research projects in my group is around data analysis and graphing. And so, this I have like a graph over on the left-hand side, and then this was an art student's interpretation of some of our research. And I always like to share that because it's beautiful, and it shows like, you have data and you have your brain and then all the things that go into it, that you suddenly, can make some conclusions. So I love this painting. So go ahead, next. So if we go back, and I apologize, it's a little small. If we go back to the ACE Bio competencies, right? So what I put are pictures of two of the competency areas where graphing could come into play. There's another one as well. Some people graph when they're designing an investigation as well. But what's in here, you have data analysis, you have statistics, data summary, that's all under analyzing, and that can relate to graphing in some way. And then conclude, it involves like creating a display of the data. But in our project on investigating students' reasoning with graphing, we realized that even these were not specific enough from when we're thinking specifically about graphing. So we went deeper for our project. Next. Go ahead, sorry. And then also looking at the BioSkills guide, it was also it wasn't very detailed for what we wanted to do in our project and even in my own teaching. So it comes up in the quantitative reasoning, and then next, it comes up in go ahead, the data interpretation evaluation, right? So those statements, they're great, but they weren't detailed enough to guide instruction, okay? So, and then you can just click to animate this. So as part of our project, and one more, we realized that there are, and Paul is amazing. I'll have to send him like, a bunch of chocolate or whiskey, I don't know, for doing my slides for me. So there are a lot of things that go into graphing. So now we've like zoomed way in detail on one part of what students are doing in investigations and research. And so they have to know about the different kinds of graph types that are available, their pros, their cons, when they would be useful. They need to have some understanding of math and use math and statistics. And also graphing really is kind of grounded in the discipline. So for example, in biology, we approach graphing differently than a chemist might, than a physicist might. And just the nature of our systems under study is so different. Biological systems are messy. There's a lot of natural biological variation that doesn't exist in other disciplines. And then creating something that can be interpretable by the person who's creating it, and then communicate to other people. So the visual, spatial, and aesthetics aspects. So a lot of things go into creating this simple little graph. Next. So we were fortunate to have some funding from the National Science Foundation, and I don't have time to go into all of the details. This is less of a research talk and more of a practical tools products talk. But we were designing some graphing assessments to reveal what students know and know how to do. And so that was part of our project, and then use our findings to create better teaching tools to support undergraduate biology students. And like, again, we've kind of zoomed way in. So go ahead. But one of the things we needed to do for this work, we were creating an assessment. And actually the assessment is going to be published soon in CourseSource, and I can put more resources up in that folder for those who are interested. We needed to think about, okay, what's the target? Like, what are the things we're going to measure? What are the things that students need to do? So we created a model, and this, we called it the Graph Construction Competency Model for Biology, or GCCM Bio. And so what we had were 4 components that you can see in that first column. Next. And then within that, and I'll show you an example of one of the components, there's a set of skills. So it kind of should remind you of the ACE bio competencies, where there's, the concept and then the skills. And then how did we get to this point? Next. Similarly, I mean, we tapped our own knowledge, our own previous research. We did some literature reviews, scoping literature reviews to kind of provide some validity evidence to what we had in our model. And we had some focus groups with biology and statistics education researchers and educators, again, to get what's like face validity. This is a framework related to graphing, and then content validity, like, yes, these are the things, there's nothing missing, this looks appropriate. Okay, so, and it's been accepted for publication. So just to kind of show you what that looks like, because you'll have this folder that has the full model, just to orient you, is that this is just an example from the graph assembly, like putting together a graph. So you have the component on the first column, and then we had these, what we call activity codes, and then definitions, right? So for graph type, like, there's so many different graph types. Do you want to do a line graph? Do you want to do a swarm plot? Do you want to do a histogram? Do you want to do a scatter plot? So many. So selecting a graph appropriate for the data type and the purpose, right? So there's lots of graphs that could be appropriate, but based on what your question was and what you're communicating and what's in the data, some are better than others. And then we have data plotting, like actually putting it together, graph structure, following the conventions for scaling, putting the variables relative to each other, and the axes, graph labeling, and graph communication. So that's just an example there, and I've used these in my own class. And so next. So I'm wrapping up. Like I said, I wanted to introduce you to some frameworks to get you thinking about, and this is more in the cognitive domain, like the knowledge and skills that students can gain in your classes, and hopefully to help support assessment. So how do you decide, right? So which learning, which learning and objectives, supposed to be objectives and outcomes, align with your goal and your context, right? You can't do everything. Go ahead. How broad or specific do you want to go with your students? Maybe you don't have time to get into the nitty gritty of like really developing their graph construction knowledge and skill. And that's okay, right? You can't do everything. You need to decide, where do you want to focus? What types of evidence for and of student learning can you gather? Go ahead. Which things do you want to assess? And do you want them to be formative assessments along the way to help the students reflect on where they are and help you adjust instruction? Or do you want them to be like, big exam, or like the poster or the chalk talk in the middle of the course, something I've done to share, intermediate kind of results? Go ahead. And then how will you measure them? Go ahead. You can use rubrics. You can have students write reflections. That could be on tests, it could be on lab practicals, it could be in surveys, interviews, depending on what your purpose is, what tools you have, and what works well in your class, and the time you have, and other things that are going on in your course that are also important. Go ahead. And then how will you use the evidence, and how will your students use the evidence, right? So is it something that is going to drive their learning, or to help motivate them, help them have that, in my experience, that it could also help them feel connected to their projects, or that they're learning, or that they're competent, that they have the ability to keep going, they have the skills needed. But sometimes you may need to justify teaching your course, just kind of zooming out, right? Do you need to provide evidence of student learning for your curricular goals in your departments, in your units, how your course is supporting that? Do you need it to demonstrate to administrators that, yes, the investment and letting you teach a course in a certain way is worthwhile? And then within this network, looking at the impact of what you're doing, and sharing with others, for example. Go ahead. So as promised, and I will add some more things, but I created a Google folder that has, I'll put this presentation in there as well. And then it has a couple of my papers, a couple of the frameworks, just so that you can study them and have them for yourself. And I can put some more things in there too. And happy to share. We all know lots of things. I'm sure you know things I don't know as well. So that's why I love, interacting and sharing and talking with people. But I'm happy to share, because I know a lot of things and I don't always know what's going to resonate with you, but I'm happy to tap my brain and add to this. And then next, I don't know if any of you went to the Connect UR conference, the Council on Undergraduate Research conference. I just got back from their meeting. It was in Grand Rapids, Michigan. And Janet Branshaw, she's at the University of Wisconsin. She and I actually went to grad school together, but she presented on a framework, which is it's a synthesis or meta framework. And it is so cool. I wish that I put her email there, because she may be willing to share it with you, or at least let you know where it stands. They did a huge literature reviews, like the ACE biocompetencies. That was a part of what they looked at to try to synthesize what's out there. And they created this meta framework for common learning outcomes for research training. And they had, as you can see there, 8 outcome areas. And thank you for putting that, Elizabeth, into the chat, that Google Drive folder link. Thank you. You can see there, foundational disciplinary knowledge, practical and cognitive research skills, the ethical and responsible research practices, communication, interpersonal skills, their self-beliefs and attitudes, knowledge and skills to pursue a research or research-related career, and then project management, which kind of came up in the chat as well. So she said that it was fine for me to kind of share at least this much with you all. They're just about to submit it, and they've been working on it for 2 years in an unfunded project, which means that she loves it and they wanted to put the time there. So that's her email there. But I wanted to let you know that it's coming, and it could be really, really useful. It has a lot of outcome statements based on a review of the literature. Okay, next. So with that, I wanted to leave enough time. I wanted to share a little bit with you. It's a very different, it's not a data talk, and more of a, just in case you didn't know, and these could be helpful for you, talk, like a tool, practical things when you're thinking about assessment and designing instruction. So my email is there, but then, also the people that have helped move a lot of these projects along. It's not just me. So just bringing, saying thanks, and thanks for funding. And also down at the bottom, the Biology Scholars Program way back when in 2012 or when I was transitioning to biology education research, they were, fundamental in supporting me there way back when. So with that, I say thank you, and I'm happy to chat. I was usually I get excited and I talk a lot, but now I'm like, woohoo! I've got you back on time, almost, almost.
Thank you
Go
so
ahead.
much, Stephanie, for such a great presentation. Really appreciate that. I'm so happy that you were invited to provide this, framework for instructional design. I'm going to open it up for questions. Please use the raise your hand feature or type it in the chat. I'd like to acknowledge those questions. I would like to ask about, I really like the figures because they speak to assessment, quite well. Could you chat a little bit about the graph smarts?
Yeah, so we were creating, it was primarily for research purposes, but we created a digital assessment that students from classes around the country have taken. And that was, we had worked with instructors to design a bunch of different scenarios. And so students graph data to test predictions within different biological contexts. And what we were wanting to do is to gather evidence to help instructors and to make recommendations for instruction. So we are publishing in CourseSource. It was accepted, kind of the back. We have like 6 backstories for students to graph in. So we have 2 like ecology, evolution, 2 kind of cell physio, and then a couple of molecular ones. And so we'll have that, all of that. We'll have all of the questions there, so that if people wanted to make use of them, and they're all mapped. All the questions are mapped onto that framework that I talked about. So we're getting evidence about students. What I didn't show you was like reflection. They're like evaluating their decisions, or that they were understanding how to represent variability in their graphs or select the appropriate variable. So everything is mapped onto that framework, and that'll be all there for people to use and adapt. Unfortunately, the platform, it was a collaboration with Symbiotic Software, SymBio, that is not available, but everything, all the materials and some of our analysis frameworks are also going to be available. And I'm not sure when it's coming out, but it's coming out soon.